which I was showing on the diagram, and the Earth is revolving all the time. So if the Earth is revolving, the path is also moving, and at any one point of time, you do not have more than 8 minutes of total eclipse. For a total solar eclipse to occur, the moon must be in conjunction with the sun. For the shadow of the moon to fall on the Earth, the SHA or GHA of the sun and the moon should be equal, and the declination should be equal and of the same name. A solar eclipse can therefore take place only on a new moon day. However, it is not necessary that it must take place on each new moon day. This is so because though the condition regarding their SHA or GHA is fulfilled on each new moon day, the condition regarding their declination may not be satisfied simultaneously, because the orbit of the moon is inclined at 5¼ degree to that of the Earth. A solar eclipse will take place only if the moon is on or near the ecliptic, which means at or near its nodes on the day of the new moon. So if all these conditions are fulfilled, we will have a solar eclipse. Now coming to
डायग्राम से बता सकते हैं कि डिक्लिनेशन सेम क्यों नहीं होगा?
I showed you on that, no, the nodes on the board also I showed you. Let me take you back to the nodes. The path of the sun is EC, ecliptic. If you remember, we discussed this yesterday. And the path of the moon is OO dash. You can see the maximum declination of the moon is 23.5. And the moon's declination is a little more. It was how many degrees? 5 degrees or 6 degrees? 5 degrees, 8 minutes. 5 degree, 8 minutes. It is more, you know. So that is why you can see in the north also the declination is going higher. South also it is going. Now, that first point of Eris is the node. First point of Eris is the node. So if the new moon is happening at that time, then you will have the eclipse. Somebody said that zero declination. From this picture, it may look zero declination because the node is there. QQ is the equinoctial, and because the intersection of the moon's path and sun's path is there, that is the node. So somebody rightly said 0 degrees, but this may not always remain 0. That's why I said declination should be same and of the same name, because the node is shifting by 19 degrees every year. If you see here, the node moves westward along the ecliptic at about 19 degrees a year, and it takes 18.6 years for the entire cycle to come back. So if the first point of Eris, that intersection point, has shifted on the ecliptic, then that condition has to be met. So if you want, I can switch on the camera and show you again. But the point is, sometimes what I have already explained, you people are asking again, which is not a problem. I can explain again. But sometimes I'm not sure whether you were paying attention or you were attending when I was clarifying that point. So that issue, I'm not too sure. Anyway, I will explain this once again over here. So let us say this is the path of the ecliptic. and this is the path of the moon. So sun is traveling on the red line and the moon is traveling on the green line. The declinations are slightly different. This is the equinoctial. Sun's declination is maximum 23.5, and this is 5 degrees something more, so 28.5, let me put it. Now, this is the node. In the book it is showing at the equinoctial, but the point which I'm trying to make is, node is the point where the path of the moon and the sun will intersect. So if the full moon is happening around this area, this time, then you have an eclipse. Now next month, again there is full moon, but you may not have an ecliptic. Okay. Because the moon would have shifted to some other point. Maybe the moon would have gone here and the sun is here. So the declinations are changing. But what is also happening is, this node is shifting westwards by 19 degrees a year along the ecliptic. That means this point of intersection is coming here after 1 year, coming here after 1 year, coming here after another 1 year, like this. So in 18 years, this will come back here, 18.5 years, which means what is happening? The path is complicated. So just try to imagine that the whole, because the axes are tilted and the bodies are taking a revolution around the sun. So the path of intersection between the two does not remain fixed at any one point. That nodes will change. Now, if the node is here, let us say if the node is here, then you can see there is a big difference between the declination. Right now, there's a big difference between the declination. Or let us say if the moon is here, there is a big difference between the declination. So the eclipse will not take place. But if the path of intersection has come here, the node has shifted like this, then definitely there will be an eclipse over here. Remember, the node is shifting. The declinations, difference in declinations are not changing too much. The declinations will remain where they are. It requires a little bit of imagination to figure this out, how this entire thing is moving. So I hope I have been able to answer your question, if not fully, but maybe partly. But like I said, you may not get it in one reading. You may have to read 2 or 3 times. You may have to draw the picture yourself and spend some moments upon it. Then probably you will be very, very clear. If still you have any doubt, you can ask me again. My suggestion is read this chapter thoroughly during the weekend, and Monday, if you have any questions, we can revise this topic a little more before we start the new topic. Is it okay?
Yes, sir.
Okay. Now let me explain to you what is a full, partial and an annular eclipse. You all can see the board now? Now if you are at this point,
Yes, sir, it is.
Yes, sir.
if you are at this point where no light from the sun is reaching, the people standing on Earth at this point, they cannot see the sun at all, which means that if this is the sun, the entire sun is getting covered by the moon, and you just see a dark shadow over there. You must have noticed, if you have witnessed a total full eclipse at any time, it becomes so dark, everyone thinks it has become night or evening. The birds start going home. all those sort of natural phenomena takes place, it becomes fully dark. Now a person standing in the umbra region. Let me also mention here, this portion is called the umbra region, and these two portions are called the penumbra. So, person standing in the penumbra region will see a partial eclipse. What is a partial eclipse? So, they will see that the sun is covering half, the moon is covering half of the sun, like this or like this, depending upon which part of the earth you are, from where you are seeing, whatever. The other part may be slightly dull. Remember, it is like this. So half you are seeing covered, half may be dull or whatever. But what is a annular eclipse? For that, I will have to slightly alter the diagram. We know that the path of the moon is elliptical. There is apogee and there is perigee. So let us say this is perigee, where the moon is close to the earth. Now let me make it apogee, where the moon is far from the earth. So now let us say the earth is little far. Earth is little far. In this case, what happens? In this case, what has happened?
Rays of light are intersecting each other.
There is, if the earth is far or the moon is far, let us say at apogee, will the moon look smaller or the moon will look bigger?
Smaller, sir.
Smaller.
The moon will look little smaller. Moon will look little smaller. So what will happen? It will not cover the entire sun. The moon will look smaller, so a ring of sun will be visible all the time. A ring of sun will be visible during that annular eclipse. This is called an annular eclipse. So there is a lot of movement going on in the solar system. Declinations are changing, paths are ecliptic, but due to very fine observations and calculations, people are able to predict. They know exactly which day there will be eclipse, which part of the earth can see. That is why they announce beforehand. But the point is, the situations differ at every time. So some people can see, some people cannot see. Some places it is partial, some places it is full, some places it may be annular, depending upon whether it is apogee or perigee. So are you clear now on the different types of solar eclipses? When I show you the video, it will be very, very clear also. One very nice, interesting phenomena also takes place. The moon itself has got mountains and valleys and all that, So when there is a total eclipse, just before the total eclipse or after the total eclipse, when the moon is moving out, first very small ray of sunlight will come, very small ray of sunlight, and it shines like a diamond. So it is called a diamond ring at that time. So if ever you get a chance to see a total solar eclipse, you must even watch for that diamond ring, it looks like a ring, diamond ring, it comes out like that. It's a very beautiful phenomena if you get a chance to observe. So that brings us to the end of solar eclipse. I will start the lunar eclipse now. Any questions you have? Otherwise, I would suggest you read the chapter again, and of course we will do it again on Monday. Any questions, gentlemen? Lunar eclipse. This is what happened day before yesterday, and it happened on a full moon. So we will see the difference between a lunar eclipse and a solar eclipse also. See, a solar eclipse you will see only in the daytime, when the sun is visible. And the lunar eclipse you will see in the night time when the moon is visible. Can we see the board now? No?
No, sir.
No, sir.
No?
Yes, sir. Now visible.
Yes, sir. No.
So, slight difference over here. Now the earth has come in between the moon and the sun. You can see the sun, the earth and the moon. Again, the sunlight is obstructed by the earth, and the earth also casts a shadow beyond itself. There is an umbra region and there is a penumbra region. This is the umbra region. Now the moon, in the previous diagram, the moon was here between the earth and the sun, but the moon is also revolving around the earth. So this is the path of the moon. 1, 2, 3, 4. Here the moon is in the open area, and here it is in the penumbra area. Here the moon is in the umbra area, and again in the half in the umbra and half in the penumbra. So the types of eclipses are total, partial and penumbral. So I'm sure most of you have seen lunar eclipses also. Let us find out the conditions of eclipse, and let us also find out what are the different types of eclipse. What does the diagram tell you? What should be the condition? 1. Now the moon is on the opposite side.
Full moon.
It has to be a full moon. It has to be a full moon. Correct. Second condition.
The declination of the sun and moon should be 0.
Declination should be 0. Again, why do you say 0?
Sir, should be same.
Yeah, because I told you, no, don't get confused by the diagram because the node was at the equinoctial. Equinoctial sun declination is 0, but the node is shifting along the ecliptic. So the declinations may change, sun and moon. The point is declination should be same. Okay. Same declination of the sun and the moon. Third point. Last time the first point which you gave me, uska opposite is the another point now. It is in opposition. Now the moon is in opposition. It is in the opposite direction. First it was in conjunction. It was here. So it means what? The GHA or SHA of the moon and the sun should be 180 degree apart. If it is in opposition, if this is bearing 0, this is bearing 180. If this is bearing 90, this is bearing 270, whatever. So the GHA, SHA is 180 degree apart. They are in opposition. It has to be a full moon. But why don't we have eclipse on every full moon? It should come 12 times a year, but it does not happen because the condition of the declination has to be fulfilled. So we said that declination has to be same if it is 2 degree, 2 degree, 5 degree, 5 degree. But gentlemen, here there is a slight difference. In the solar eclipse, it was same declination, same name. In this case, it is same declination, opposite name. So if the sun is north declination, moon has to be south declination. And if the sun is south, the moon has to be north. So remember these conditions of which will cause a lunar eclipse. I will take you to the summary. It is almost the same. And then I will also show you what is the total, partial and penumbral. It is almost the same the way we spoke about the sun. The moon gets completely hidden by the shadow of the earth. The moon gets completely hidden by the shadow of the earth. So you will not see the moon at all. In the partial, you will see half.
Right.
In the partial, you will again see half the moon getting covered by the shadow of the earth. The other half is in the penumbra region. The other half is in the penumbra region, this top figure. So the moon will not be so bright. The moon will not be so bright. But what is a penumbral eclipse? This position, number 2, is the penumbral eclipse, when the moon is only the full moon, entire moon is in the penumbra region. Sometimes you will not be able to notice the difference, cloudy night or whatever, even if it is a clear night. See what is happening in the penumbral eclipse. Only the brightness of the moon will diminish. The full moon is there, but it is not so bright. If you have studied about it, and if you are watching closely, you will be able to see it in the sense. First, let us say this moon is very bright. A little portion of it will become less bright. A little portion will become less bright. And then the entire moon will become less bright. Less bright. The moon will be there, but its brightness will be diminished. So, any questions on the board? Otherwise, I'll remove the board and take you to the summary in the book, and then I can show you a small video which will also help you understand the topic. Any questions on the board with the diagram, anything? It is there in the book also, so you can read again. Shall I remove the board or switch off the camera?
Yes, sir.
Yes,
Yes,
sir.
sir.
Okay. So same diagram you can see over here. 7.7. The earth will cast a shadow. The moon is not self-luminous. It is being lit up by the light from the sun. A lunar eclipse therefore takes place when the moon passes through the earth's shadow. This can happen only when the moon is in opposition with the sun, opposite side. Lunar eclipse may be of three types: total, penumbral, and partial. When the moon is entirely within the umbra of the earth, no light from the sun reaches the entire moon, thus becomes invisible. It is a total eclipse. When the moon is entirely within the penumbra region, a part of the sun's rays fall over the entire illuminated hemisphere of the moon. When you draw the diagram, you will see that the rays of the sun, from one side all the rays are going, from the other side no ray is going. So we say partly it is getting illuminated. So we see the moon with greatly diminished brilliance, and it is called a penumbral eclipse. And when the moon is partly within the umbra and partly within the penumbra, half. So what is visible is the penumbra diminished, and what is not visible is covered. It becomes a partial eclipse. Now, important part. Since the moon must be in opposition, it can take place only on a full moon day. Day before also was a full moon day, Buddha Purnima. So they had an eclipse. Because as the shadow of the GHA and SHA should differ by nearly 180 degree, and the declination should be nearly equal but of opposite name. A lunar eclipse need not take place on all full moon days, because though the condition regarding the SHA GHA is satisfied on each full moon, the condition regarding the declination may not simultaneously be satisfied, as the moon's orbit is inclined to the plane of the ecliptic. A lunar eclipse will take place only if the moon is on or near the ecliptic, that is at its nodes, at or near its nodes on full moon day. So this point is important, gentlemen. It has to be near the nodes. So the declination has to be the same name or opposite name, depending on which eclipse. The maximum
Sir,
number of
why does moon
eclipses.
appear red during lunar eclipse?
Why does it appear red during?
Lunar eclipse.
Yeah, it's a good question. Have you noticed it looks red?
Yes, sir.
So what is your theory?
सर आइडिया नहीं है इसलिए पूछा था
पंडित लोग क्या बोलते हैं, लाल क्यों है, गुस्सा हो गया मुन?
बूढ़ा हो गया मुंह।
पंडित सर बहुत कुछ बोलते हैं.
Anyway, the video which I will show explains it very beautifully. It is because of the refraction of light. The sun is light is, different colors. So the blue refracts a little less than the red. So the red light part hits the moon, so that gets illuminated. So you will see in the video. Good question. So let's move on. The maximum number of eclipses that can take place in a year is 7. of which 4 or 5 must be solar. The minimum number of eclipses that must occur each year is 2, both of which must be solar. So if there are 2 eclipses occurring, they will be both solar. But if there are more, maximum only 7 can take place, out of which 4 or 5 must be solar. So this is how the bodies are moving, and this is how it is not fixed that every year there will be 7 or 5 or 4 or 2. So whenever the situation arises, whatever conditions we have discussed on top, there will be an eclipse. Though more solar eclipses take place, but more people see the lunar eclipse. Why? Can anyone tell me? Though more solar eclipses are taking place, but it is witnessed more people see the lunar eclipse. Why? Any idea?
सर सोलर एक्लिप्स जहाँ होगा तो वो बस पेनम्बरा और अम्ब्रा में ही दिखेगा यूजुअली.
Yeah, solar eclipse you can see as a narrow cone, you know, the umbra and the penumbra is a narrow cone because the moon is small and it casts a small shadow on the earth. Shadow भी small है moon का और इसीलिए कम लोग देखते हैं. But the moon, the earth shadow is big. That is one. Second, the entire night sky will be able to see people who are having night. Half of the earth is having night and they all can see the moon. So more people witness the lunar eclipse. So there in the video also we will see very clearly, they will show you how that is possible. This is so beautiful because during a lunar eclipse, the entire hemisphere of the earth facing the moon sees the eclipse. The solar eclipse is, however, seen only over a comparatively small area. So the lunar eclipse is passing through a large shadow of the earth and the solar eclipse, small shadow of the moon. Occultation. Just because it has come on the screen, I will tell you what is occultation. Now, when the moon is moving across the sky, definitely if it can come in the path of the sun, it can come in the path of the planets and stars also. Am I right? Yes or no? If the moon can,
Yes.
if the moon can obstruct the path of the sun and stop the light coming from the sun to the earth, the moon can obstruct the planet and the sky also on the celestial sphere. So there may be some times when the moon is obstructing some planet or star and you can't see that planet. That is called occultation. Okay, nothing much over there.
Yes.
Only you have to see if the SHs of the sun, the moon, and the other bodies are same, then declination probably you will find that. So these are all theoretical questions which you must go through and find the answers in the book. I will now show you those. I think I got 2 videos. And then this is time chapter. I said earlier that next week I will first do the celestial sphere chapter, which might take 1 or 2 days depending upon how much you can grasp. Better read that chapter, celestial sphere, before you come. You have a full weekend. And then I will be starting with time. Time also is a very long and complicated chapter. So next week probably I'll be doing only these 2 chapters. So read as much as you can. So shall I go to the video now? Are you ready?
Yes, sir.